Good afternoon, everybody. Thanks for coming. I hope you guys had good reInvent so far. The pitch is high? Okay. We will be talking about our experience with how we migrated our reporting and analytics platform from Oracle to RDS today. Primarily, we will concentrate on MySQL, and I will have one slide or so for Aurora. So let's begin. I'll give a brief introduction of what Gallup is. I'm assuming people know about Gallup. We are a polling firm. We do a lot of data collection. That's what we are known for. But primarily, our business is more on management consulting, like brand management, loyalty, employee engagement, those kinds of things. So we collect data and analyze and give recommendations, that kind of thing. Why AWS? What are the various non-database cultural issues that you face? We will go in detail about that. And obviously, the MySQL benefits, challenges, and a very brief rundown on our solution architecture. Everybody able to hear me? Okay. There's an echo coming, so anyways. We'll talk about various processes and DevOps changes that we need to do when you're migrating to the cloud. We will talk about that and briefly go over our RDS Aurora implementations. And we will have some conclusion points. By no means, this is a comparative study of Oracle versus MySQL. This is just our experience on what we went through. As I was alluding to before, Gallup, we have been in this business of data collection, survey polling for the last 70, 80 years, actually. So we have data right from 1940s. Late 1930s, we started collecting data. So we are polling all kinds of stuff from social sciences area, especially. Enough of Gallup. So why we went with AWS? What was the problem statement that we were facing? So as usual, it's the same thing. For every time you build a system, you want a scalable and very richly analytical capability platform. Obviously, cost effective, so no big changes there in terms of general expectations. We wanted also a rich analytical capabilities. And more we seem to get a lot of clients who are asking for encryption for all of their data, so it's not surprising for you folks. But 10 years ago, it was not that case. Obviously, 24/7, high availability, replication. We also seem to be running into a lot of issues with Patriot Act, which is if the data crosses US borders, the US government has access to it. So a lot of our multinational clients, especially from Europe, they don't want the data to be housed in US. So that's also a big concern for us, because if you want to do data collection, reporting, analysis, we can't bring the data to US. So multi-region data segregation. Also, what we have seen is more clients want no data commingling, which means you can't store the client's data, like client A and client B, in the same database, because they are paranoid for all the various reasons, especially the government agencies. So within the same region, you want to segregate the data, and also you want to distribute the data across globally for compliance reasons. Also, ease of administration. Currently, we have lots of DBAs working through our Oracle infrastructure, along with other databases that we have, like Microsoft SQL Server. Why AWS? So basically, it's been very cost effective from our analysis. Traditional existing models are locked down to physical hardware. So basically, for example, if you take any vendor out there, we have a CPU-based licensing model. So that's a big cost for us. And also, we need to do a lot of hardware investments for getting all this physical hardware. Obviously, you also have the DBA slash system administration overhead. In AWS, a lot of these things probably go away to an extent. Also, as I alluded before, the Patriot Act, cross-border data transfer, all these things perfectly align with what AWS offers, actually. So you can replicate your entire infrastructure. For example, if we have an infrastructure in Virginia, you can replicate the whole infrastructure in Frankfurt, Germany. So that is the model that we are architecting. Also, high availability replication. So we can replicate data faster with cost effectiveness primarily. Also, it's a traditional problem in our industry. You have peaks of load. So for example, if a bank signs up with Gallup, they have 100,000 user base. So suddenly overnight we have a 100,000 user base expansion of our offering. There is no way you can plan for this because it's a sale that went. So AWS actually offers us to scale the resources as we need. One of the other things is we tend to have a lot of activity. Obviously, everybody has this problem. We tend to have, there are peak hours and off-peak hours. Peak hours, we generally have a lot of transactional stuff going on, and off-peak hours, we have a lot of ad hoc jobs, processing, those kinds of things going on. We always had a need for more hardware for these off-peak hour jobs. And in the traditional model, if you invest in hardware and software, you won't get the bang for the buck. And that's one of the reasons, one of the limitations that we have seen for a decade now. In AWS, actually, we can bump up our hardware as we need. We also have non-continuous loads demands. There are real-time as well as batch requirements for data analysis. We also have, AWS also offers not only a relational engine, but it also offers us a very big data type platform, which is absolutely essential for us. We experimented with housing big data POC within our own premises, but there is a lot of overhead and a lot of learning curve to do all those things, not only on development, but also on the administration side. So in the AWS world, you have all these inbuilt components which are highly scalable and very attractive to us, because recently they just released, not just released, they released some time back Kinesis, which is a complex event processing system, and we have an inbuilt, in-house built system that sort of operates like that, but the scale is something that we were planning to go in detail, but now we don't need to do because Amazon keeps on introducing new and newer components so fast that we are unable to catch up. So we just build a Firehose type thing on Kinesis, and today's keynote, they said they have it. So it's so fast, the amount of development that they do and the amount of things that they release, it's hard to catch up. And anything we invest, generally they always have a new service coming out which fixes that thing. Okay. A couple of non-database considerations. Process. This is the biggest challenge we have. We have a stable processes build, which has been optimized over a decade. We have a huge legacy overhead on our design, because requirements 10 years ago, 15 years ago, is not the same now. So again, it's a cultural change in a lot of ways. Whereas in cloud, you seem to have new processes that not many people get it. It's just a learning curve for a lot of folks. It's not just administrative side, but also on the development side. New tool sets, data is not within premises. So this is a very important point. A lot of clients previously always ask, are you housing the data or is it in the cloud? If it is in the cloud, we don't want anything to do with you guys. But in the last couple of years, things are changing where they are open to asking, okay, what cloud platform do you use and what kind of security, encryptions, and how do you have data stored? Is it at rest encrypted? In transit, what is the status? Those kinds of things. So people are more, the cultural change is seeping in, is what I'm saying. Obviously, data segregation. Also, data migration is one huge thing. So do you want to send the data over public HTTPS encrypted, or do you want to use a VPC and use a tunnel VPN to extend your own network to Amazon? In that way, it's just same as when you run migration internally. So there are a lot of options. It depends on your data sets. Obviously, the VPN bandwidth is big deal. So if you have a lot of data that you need to transfer, public is cheaper. If you want to go through VPN, you need to have bandwidth between your company's network and Amazon. So a couple of things that you want to consider. Also, the data migration, do you want to make it secure? So do you want to encrypt when the data is pushed out? Both the databases as well as the ETL jobs that move the data. Okay. Other non-database considerations, technical. This has been the biggest challenge for us. I'm assuming everybody who's here has Oracle implementation. So obviously you have a data warehouse which has a standard dimensional model. You have star schemas, you have ETL, you have staging areas. So all these things require a lot of resources that are very well versed with database development. So you have people who are very proficient in PL SQL procedures. You have people who are very proficient in data modeling. So our team composition, we are around 50 people in our group. Majority of them seem to be on the database developer stack because that's our legacy. That's how we have developed over the years. We have a huge strength on the UI side, and we have a medium type strength on the service layer. So it's a big challenge because on AWS side, everything is on the services side. So the service layer pretty much dominates the whole space. So that's one big challenge. It's hard to find people with AWS skill sets, obviously. But one good news is Oracle skills are portable, meaning if you have written stored procedures and if you plan to write stored procedures in MySQL, majority of time the skills are portable, but there are a lot of gotchas here and there where you need to do tweaks in your code. You're used to some set of programming idioms. You're used to some capabilities that Oracle has spoiled you for years, and you don't have those kinds of things available in MySQL. So a lot of deficiencies and a lot of peculiarities in MySQL, RDS MySQL. So this is no means a artifact specific to RDS. It's more of MySQL capabilities. These are. Obviously, you have data synchronization issues that you have to always go through. In a standard data warehousing model, the data gets collected, it gets moved, you need to do bookkeeping. So data synchronization, now the bigger challenge is, do you want to do synchronization on-premise and then send the payload, or do you want to sync between those two? It all depends on how much data and what's the throughput that you want. Again, there are a lot of tools out there. Do you want to build versus buy? So these are some of the considerations that you need to keep in mind. From the technical side, data migration, we implemented on RDS as our reporting repository, with Amazon S3 being our unified global data store. So the ETL, I will go into detail on this one. ETL just pumps files to S3, and from S3, you pick up all the data into RDS. We have a lot of ad hoc custom data analytical deliverables. So we have a lot of researchers, data researchers who like to have files. They don't seem to be proficient in a lot of SQL, that kind of thing. So they want files, meaning they want data so that they can run their own stat analysis. So S3 seems to be perfect fit for us on that one. Also, when you create these things, you can have cross-domain data analysis. What I mean by that is, if you have dataset 1, which talks about customer, and dataset 2, which talks about completely different thing. In a standard relational modeling that you do, these are two different warehouses because they are completely not related for reporting and reporting purposes. But it seems the researchers want to try all combinations to find patterns. So they want to get these two data sets to do analysis. So S3 seems to be perfect for that, because in one file system, one global file system, we can give all types of files. Couple of interesting things. We use heavily SQS, the queuing. So in Oracle, you have something called advanced queues, AQ. So we are heavily dependent on it. In this world, its equivalent would be Amazon SQS, but it is not a conventional queue. So first in, first out doesn't happen. So again, it says queue, but there are some peculiarities with it. So if you have a transaction that needs to be ordered, SQS, you need to do a lot more to get those things ironed out. SQS by design is not a conventional queue. Again, other thing is Amazon S3. It's a global file system where you can put data and access in a distributed way, but as soon as you write, it is not guaranteed that you can read. So it is, eventually it is consistent. That's S3, which means if you have a process that reads file after it has been written, and if there is a chain of events, you need to account for this eventual consistency of retries or something in your code. Obviously, there are a lot of variable latencies and performances of various services. Everything doesn't work as advertised. That's my personal experience. So every component has its own peculiarities. So until you delve into the details, it's hard to quantify. And there are no general guidelines on this. It's up to your use case and also on what components you're using. MySQL benefits. It's a good Oracle alternative, but it is not as rich as Oracle, by no means. It's a cost-effective, and the administration, we are managing all of our databases with pretty much 1 or 2 DBAs. It's obviously scalable. You can resize your instances. If you have the money, you can resize it for a couple of days and then bring down the size. There are also read instances available, read replicas. This is a major difference between MySQL and Aurora. You replicate your tables/database for a read replica in MySQL, whereas it's not replicated in Aurora. So there are a lot of lag issues. When I say about lag, what it means is if you write something to MySQL, the read instance won't pick up that change because there is lag because of replication and all those things. So if you have a query that goes and writes to the master and then reads from the read instance, you have issues in case you don't account for it. So that's one interesting thing. But read instances are really helpful, especially since our reporting system is more of a traditional warehousing system, which means majority of the day it's all reads. During nights we have a lot of writes, which means majority of reads is the nature of our system, which means read replicas are really, really helpful. But again, it's up to you on how you segregate your queries to the read instances versus the master. Failovers and all those things you need to account for. Ad hoc needs. So when the researchers come and say, we need this data set, I'm open to learning SQL, so how do I get access? In today's world, we don't give them access to our Oracle production instances because they can write a query and that can completely really harm your production workloads. So these read replicas are a good way of creating an instance for them for a day or 2 or a week and let them do whatever they want. And it doesn't affect any of our production instances. So these are some of the ad hoc needs that we are very happy with the read replica architecture. Obviously, multi-AZ regions, key encryption using key management service, all these things are pretty effective on RDS. Security and encryption, as I stated before, the KMS, we use KMS, key management service, to create a global key for all of our data infrastructure. And that key, Amazon rotates, we can rotate it every year without disturbing any of our processes. And Amazon pretty much takes care of decryption when you query it and encrypting when you store it. That kind of architecture. So encrypting your data is pretty seamless, is what I'm saying. All you need to do is, when you create your RDS instances, you need to specify which KMS key for you to encrypt. Obviously, as I stated, Oracle is far more productive and feature-rich. It has AQs, it can write files, it can send a request to HTTP server, it can email, you can do all kinds of things in Oracle. So when your database developers move from Oracle to MySQL, it's a big challenge. Because the things that you're used to so seamlessly, you can do a lot of things, are not possible in MySQL. There are no integrations with any of AWS components. I was just talking today to the product manager group on Aurora that we can't write a file from a stored procedure to S3, or read a file from S3 in a stored procedure. So in Oracle world, you have these job executions, job scheduling, and all these concepts, which means at 2 a.m., one of my job wakes up, starts processing data, and notifies through AQ that the data is ready. These kinds of things are pretty normal. In this world, the job wakes up, fine, you can schedule, and it is done aggregation, that's fine, but then it doesn't know how to notify, because it can't. Because it can't send an event to SQS, neither it can take its payload and write to S3, which probably people can read. All these capabilities don't exist within the database. Outside of the database, absolutely, you can do all these things. But coming from database development group, majority of them who are database developers, we can't train them overnight to learn Java or, yes.
All these capabilities exist in Oracle RDS or not? If you're saying Oracle and MySQL, I can understand and agree with you. But what about if I'm moving on-prem Oracle to an RDS Oracle?
If it is Oracle to Oracle, you don't lose anything. If you have licenses, you can migrate. So the question is, if we move Oracle from on-premises to RDS Oracle in Amazon, will we have these capabilities or not? You have AQ, and you have to have your application server use AQ libraries to do whatever it needs to do. Developer productivity. This is one of the biggest heartburns that I get from my development team. There is no concept of packages in MySQL. So you need to keep writing individual stored procedures. So that gets messy. But the good news is, performance-wise, you don't take a hit at all. But the bad news is, when you log in, you'll see tons and tons of stored procedures, if you are very heavy into stored procedures. It looks like it's all over scattered. There are no package level attributes. Global scoping is doesn't exist in MySQL. Everything is locked to a session, meaning if you open a connection, any data that you store in a temporary table or anything, you cannot share with other sessions. In Oracle, you can do a lot of these things with global concepts. There is none whatsoever. In Oracle, obviously, you have a lot of data structures, better data structure support. So again, you have to do all this basic plumbing yourself. Temporary tables pretty much is the solution for everything in MySQL. So we have to use a lot of my temporary tables to do a lot of basic things that we are so used to in Oracle. I will go those into detail. These are specifics. You cannot have cursor parameters in your procedures. There is no dynamic SQL concept, like there is no execute immediate punch a string. That doesn't exist. Debugging and logging. Other than whatever the standard tabular tables that you get from MySQL, it's tough. Especially if you want to debug on a read instance, where do you write? So these are interesting challenges that come up in this architecture. You cannot declare cursors with dynamic SQLs. Global temporary tables don't exist. Support for subqueries in from clauses are not there. Again, we can't send a notification, whether it is a HTTP endpoint where we notify our application server that data is ready, please invalidate your cache. Those kinds of linkages you can't do. Email notification capability doesn't exist. As I stated before, two-way integration with Amazon S3 doesn't exist. Since we have globalized everything on our S3, this is a big problem for us. As I stated, SQS, there is no AQ capabilities. So this is a very high-level picture of our solution architecture. I'll get to that. So we use RDS MySQL as I might have already told you. We didn't go with Aurora primarily because Aurora doesn't support encryption. So that is supposed to be released very soon. Data at rest encryption currently is not supported in Aurora, whereas in MySQL it does exist. We use stored procedures extensively. That's something that we had to do because of our technical teams. We wrote an application called RDS++, no pun intended there. This actually helps us integrate stored procedures with SQS, SNS, SES, S3. So this is a general framework that we have built in-house where database stored procedures can start integrating with S3, read writes from S3, send an email, send notifications. It can send NQ or DQ message, all those things we have built. But you have to invest in your application layer a little bit on that one. It's an XML/JSON-based definitions kind of language. So stored procedure defines something, and then the Java layer picks it up and does what is written in that language. We have Tomcat. We go with Tomcat Java instances for our application server on reporting. We do the standard EC2 load balancing, auto scaling, and we lock down our QA and QA infrastructure into the QA VPC and prod infrastructure in prod VPCs. We also have a separate Java dedicated, Tomcat Java dedicated instances for our data infrastructure, which run all of our ETL. So there is Tomcat Java instances for the regular reporting, and there is ETL instances, and that is something that actually does run the RDS++ that I was talking about. We use Elastic Cache for our context management, and all of our data collection comes through SQS to S3, and ETL picks up that S3 also from S3. For ETL, when you want to, you have a Tomcat Java instance on the cloud, but on premises also you need somebody to send the data. So there is a Tomcat Java instance for on premises for us also. So there are two, one is on premise and one is on the cloud for our ETL, and then there is reporting infrastructure on the cloud, which generally serves all client requests. We use a lot of Java and CLI to transfer data. I'm a big fan and proponent of CLI actually. It completely is so transparent and so easy to do. If you're very well versed in batch scripting, this is a good alternative for you to write a lot of complex processes. So Oracle writes all the data to a file system, and our data ETL system on premises picks those files, massages it, and sends it over the wire using CLI/Java to S3, and then our data servers pick up those files and load it up to RDS. So the data that we transfer might be configuration information, it can be the regular data itself, it can be lots of things, but generally that is the mechanism that we use. Okay, that's the Gallop network. We have Oracle databases that write to the shared directories, which are picked up by the Tomcat Java instance for our QA and prod environments. And you have the Amazon VPCs. We have one for QA and one for prod. And there is a VPN connection for us to tunnel through to Amazon. We have S3 where the data is written. Our data Tomcat instance servers pick up those data. So they read and write to S3, and they dump it into RDS MySQL. And they pick up some stuff from RDS MySQL, and using RDS++, they write it to S3. Our external reporting, we have ELBs, which are sitting on another Tomcat instances, and we use a lot of our content delivery using CloudFront. The regular pieces of the puzzle for scalability, Elastic Cache for distributed context management. We use Kinesis for a lot of logging. So all of our layers send events on what they're doing into Kinesis, and from Kinesis, we load it into S3. So after today's keynote, whatever we have developed for that now comes prepackaged with something called Amazon Kinesis Firehose. So all of our work, we probably need to revert in case we want to use that. And as I stated, all these components can read or write to S3, and they are also linked to our Tomcat instances on our external. And using RDS++, all the components can talk to each other. So this is how we orchestrate it. So this maximizes on our strengths, which is a lot of database developers. It covers a lot of gaps in current capabilities that we have on Amazon ecosystem, especially related to databases. And it fits our needs for now. It's not like we have solved the whole problem. So we have external reporting and data integrations directly going through web services to SQS. We pull a lot of content from other systems for decorative elements like, hey, by the way, I need internationalization piece of text for this code name. So we go to externally and pick up from our content management system. So all these assemblage happens. Obviously, developer VMs, we have Jenkins for our build. Developer, when you build your VMs, or if you have your own desktop machines, you need to have VPN. If you have VPN, then what happens is developers don't notice that they are actually going to the cloud to do their development. It's seamless. So we use VPN to make sure that developers don't need to have EC2 instances, actually. They can have their own desktops that they're used to, and they can do a lot of builds from there. Our Jenkins system is also on our network for historical reasons. So we're using VPN, we push code. Okay, couple of MySQL things that we have faced and how we solved it. But this is by no means the only way to do these things, but this is something that we have done. Package scope variables, we use a lot of session variables, which get shared by all stored procedures. It's a bad thing, but that's the only way we can work through. So if somebody creates a variable in one procedure and they call another procedure, that variable can be accessed by the other procedure. So there is no local concept. So we have to work through those things. How we solve the cursor with dynamic SQL? Using temporary tables. So this is just a brief sample code. So how do you write dynamic SQL? So you create a temporary table, then you you create your own SQL statement and then execute it. So we built the temporary table, we built the statement, and then we prepare it and loop, and we got a cursor. Very similar, execute immediate capabilities that you have in Oracle. How do you do it? Again, you use session variables, use temporary tables, and do the same. So a lot of temporary tables we use, which means you need to have a good sizing on your databases, especially the buffer cache. So we are doing a very phased transition. So our first phase is what we have moved to AWS, which is just doing reporting. The second phase, we will do a lot of data collection also on the cloud. For our initial release, we had 400 plus stored procedures and 200 plus tables. We have to build another 5 to 10 more products. So just imagine how many stored procedures we will write. We do support only our aggregate data from Oracle. We don't move all of our respondent data because that's a big project by itself. We just move the aggregate data so that we can report on the cloud, and that seemed more easier way to get a lot of our development teams understand, learn about AWS, get familiarized with AWS before we go into the next phase, which is a lot of heavy lifting that we have to do. We have to support configuration systems because client A wants this way the data to be, client B wants this way, and all this configuration information we already collect on Oracle. We need to ship this to the cloud so that the reporting system on the cloud can also take a look at it. As I stated, RDS++ is what we built, which gives us integrations between the database, stored procedures versus all the AWS components. One interesting tidbit, in our definition, what we have said is if you get this SQS event, you can say, call this stored procedure after you get this SQS event, which means we can actually make seamless job execution. So we say, I am interested in this queue called survey, and when you get the payload, call insert survey stored procedure with the payload. So in our definition language, we say, I'm interested in this queue called survey, and post stored procedure integration, meaning after the payload you get, call the stored procedure. In that way, everything is well integrated. Process and DevOps, we use GitHub a lot. Jenkins for Java development, deployment, sorry. DB code deployment is interesting. One of the things is when you compile stored procedures in Oracle, you can get a brief downtime for your production systems that use those stored procedures. The reason being the compilation is global in scope in Oracle, whereas in MySQL it is at a session level. So you don't seem to get those exceptions, which means you can deploy more often. Currently, we do a lot of manual deployment, just like forever we have done in Oracle, where you send the scripts to the DBA. We are going with the conservative route for now. For our auto scaling, we use Chef with the recipes on EC2. We have a clone of production for our stress environment. A brief description of stress testing. So when you want to do stress testing on our on-premise environment, you have to have a lot of investment that you have to make. The data has to be replicated, production workloads data has to be replicated, or you need to create your own data set. You need to have all the application servers, all the integrations, and all the teams that are owning those applications need to be involved if you want to do enterprise level stress testing. Whereas in Amazon, you can use the same scripts that copy your infrastructure and move to Frankfurt, Germany, to copy your infrastructure and create a stress environment. And your JMeter scripts can, actually the stress testing scripts can have the script of formation of all the stress environment, run this test, and then completely remove all the components that it has created. So that kind of flexibility you will have. And as part of your creation of your scripts, you can specify various instance sizing and all those things. So we are halfway there in those things, but as part of our multi-region deployment next year, we will have those things fully automated. We see a huge advantage there. It took us a long time to do that on-premises for stress. Here, within 2 weeks, we were able to deploy an identical production system. And half of the time, it was not Amazon's inefficiencies or anything. It's more of us learning about how to do this. For all of our code, we move all of our code deployment to S3. So our WAR files, our SQL scripts, all those things get loaded from Jenkins using S3 plugin to S3. And then Jenkins calls a script on these machines which sync up through S3 and then deploy it. Why we need to do that? It's pretty simple. So Jenkins using SSH and AWS keys using S3 plugin will write it to Amazon S3. Our QA machines using the CLI pick up that code and deploy it. Why we need to put it in S3? For us, if you want auto scaling, you need to tell your deployer, whether it's Chef or any other alternatives, where to pick up the latest code. So S3 seems to be one universal answer for a lot of things. So we have Chef that can read from S3, create a new server, and put it in the load balancer so that you can expand. When your CPU, you're having a heavy traffic, you can do all these things. We have been working with Aurora for some time now. We ran into a lot of stored procedure issues with it, but all of them seem to be fixed before the general release. We like that we can have more read instances because that is what we probably, that's one of the biggest attractions we have, because a lot of our ad hoc needs, research needs, read-only workloads that we have. Comparatively to MySQL versus Aurora, you have a difference of minutes versus milliseconds. So there is a lot less lag. Obviously, the replication and high availability are big key factors. Our hope is using Aurora, we will have more integration points with AWS in future. Package support, basic tracing abilities on the database. Tracing is tough on MySQL. In case if you guys are used to TK profs, there is nothing comparable. So if you want to debug a stored procedure, it's going to take a while. You can know SQLs. There are some logs which tell you what queries are running slow, but what are the various events that happen in the query to run slow? You have to work on it a lot. There are no easy way out there. We are waiting for our encryption for our production rollout on Aurora. Conclusion, AWS seems to be a very right fit for us, whether it is about scalability, cost effectiveness, challenging business needs. People don't want data to come to US. We want to replicate it in Frankfurt. We want to have data segregation within US itself because some client is paranoid that their data is commingling with other clients' data. So all these things, AWS seems to answer all those questions pretty seamlessly. And it is pretty good cost-effective alternative to Oracle. But we are hoping that there will be better integration with other AWS components within Aurora so that database developers can hopefully easily transition, not easily, but at least we can make them transition better from very highly rich environments to RDS.